Hey, it's Mr. Barr, and this is Best Fit Line Equations. Best Fit Line Equations. Our learning goal, I can use that is a difficult word. Let's start this again. I am Mr. Barr. This is the Best Fit Line Equation video, and our learning goal is I can use statistics to understand the world around me. Why? Because information is everywhere. I want to understand it and become an informed citizen. Scatter plots are great, but how can we use scatter plots to actually make predictions? Do you know how to draw in a best fit line? You do. Can you create that equation for a line? Well, you will. Today, that's the goal, to create the equation for a best fit line. Once we have the equation, we can use it to make predictions. A best fit line is the line that best describes the data in a scatter plot. And the equation we like to use for it is y equals mx plus b, which makes me want to sing a song. It's time to sing a song. It's time to sing a song. Won't you sing along? It's time to sing a song. Boom, I am out of focus. But as soon as I move, I'm still out of focus. Doesn't matter, I can sing even if I'm out of focus. How about that? That's even worse. How about that? That's even worse. And now I'm gonna drop stuff. I don't even know where I am. How about, dude, I like my other camera that does autofocus. Oh, I'm getting close. Yeah, well, this is as good as we're getting. Okay, hey, grab a mug. Grab a mug. You got a mug? Bring it down. Here we go. Y equals mx plus b. 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 Cheers. There we go. So we need to know that song because we're going to be doing some slope-intercept stuff here. And do you know what m and b are? Well, let's get this into our notes. Here we go. Some notes, some notes, some notes. Here come the notes. Best fit line equations. Start with your name and the title. Best fit line equations, and then we're going to do a thinking map. Y equals mx plus b. Tell me everything you know about m and b. What do we know about m? M is the slope. Well, what does that mean? Well, the slope is rise over run. Well, what is b? B is the y-intercept. Which is barely going to fit on my paper. What else do we know about b? Well, remember Liam the leprechaun? This is Liam's b. Which reminds me over here, this is Liam's move. What else? Slope, rise over run, Liam's move. How about rate of change? And how over here, why don't we call this the start? And let's see how close. Rate of change. See if I missed anything. How did I do? Slope, move. Liam's move, rise over run, rate of change. I think we got it all. Y-intercept, B, and start. We got it. Good job. Okay. How do you make a peanut butter and jelly sandwich? Well, you need to get peanut butter and jelly. How do you make a slope-intercept equation? Well, you need the slope and the y-intercept. So what we're going to do here is something we've actually done before, except it starts as a scatter plot. So we have a scatter plot. We draw in the best fit line, and then we build the equation. So I have a scatter plot. Scatter plot. There's my scatter plot. Step 1, I draw the best fit line. Cool. Now, I find 2 good points. You know what? That best fit line has to go through the y-intercept. Oh, you know, in this case it goes 0, 0. Okay. Find 2 good points. Now, those 2 good points are points that are on the line. It's not scatter plot points. It's 2 points that are on the line. Find 2 good points on the line. Draw in your slope triangle. This is all stuff that we've done before. The only new part is step 1, where we have to draw in the line. Step 4, count the rise and run. One, two, three, 4. Put the rise over the run to get the slope. And we know that the m is the slope. If it's a negative line, you have to add the negative. Add negative if line is negative. So we have our slope at this top point. Well, what do I still need? I still need the b. And the b I get just by looking. In this case, the b is right here at 0. So right here, I know my b equals 0, and my m equals 4/3. And to finish it off, I plug it all into y equals mx plus b. which in this case would be y equals 4/3 x plus 0. I plugged in my b and I plugged in my m. 4/3, it's kind of hard to see that 3, isn't it? Let me darken that in. Y equals 4/3 x plus 0. Y equals the slope that I calculated and the b that I got by looking at it. All right, so those are your notes, and the rest of this is going to be practicing. So watch me do a couple of these. So here I have my line, and step 1, let's see, step 1 says draw the best fit line. That's done. Step 2 says find 2 good points that are on the line. Okay, 2 good points. You know what? That's a really good point right there. You know what? That's a really good point right there. 2 good points. Draw on my slope triangle. Okay, what's the rise? The rise is 12, and the run is 1.5. So my rise is 12 over 1.5. And you know, let's do that on a calculator and see what is 12 divided by 1.5, because that's kind of a funny number. 8. So my slope is 8. My y-intercept right here is 0. So let's plug it all in. Y equals 8x plus 0. We just built the equation. Y equals 8x plus 0. There it is, y equals 8x plus 0. Looks good. So now that we have that, let's actually use this equation. How far would the runner go in 7 hours? So think about this. In 1 hour, so what does the 8 mean? The 8 means that he is going every hour 8 miles. 1 hour, 8 miles. 2 hours, 16 miles. 3 hours, 24 miles. 4 hours, 32. How far would he go in 7 hours? In 7 hours, this would be y equals 8 times 7, which would be 56 miles. That's like ultra marathon, isn't it? Let's try another one. I start by drawing in the best fit line. Well, the best fit line is already there. I find 2 good points. Well, this was a nice one. I had 2 points right there. I draw in my slope triangle. I count my rise, which is 20. I count my run, which is 5, 10, 15. I have to look down here. So my slope is 20 over 15, which is 4/3. And my y-intercept, it's right there. I think that's at about 45. I have my b, I have my m, y equals m x plus b, and I plug it in. All right, so here I wrote it as 4/3, and that's the same thing as 1.33 repeating. So what does this mean? So let's plug in a 0. If I study for 0 minutes, I would get a score of 45. If I study for 1 minute, that means my score would go up by 1.33. What if I study for 70 minutes? Well, let's do 1.33333 times 70 minutes plus the 45. I would get a score of 138. If I study for 70 minutes, my score would be 138. Ooh, this is a negative line, isn't it? I find 2 good points on it. You know what? Okay, let's use that one right there. It's a pretty good point. That's okay. That one, that's a good point right there. Let's take those 2 points. I think those are the best points on the line for us. Okay, what's the rise? 5, 10, 15, 20. What's the run? 1, 2, 3, 4, 5. So my slope is 20 over 5, which is 4, but it's a negative. Why is it a negative? Because Mr. Barr's name is going downhill. And my y-intercept, you know what? Let's call that, it's about an 80 or a 79. We'll go with the 79. Y equals mx plus, I'm going to go with an 80 because I think that's probably what I have on the next slide. Oh, I went with the 78. Okay. Either way, we'll go with the 78. What does the negative 4 mean? That means that for every 1 hour of exercise, my heart rate goes down by 4 beats. So let's plug a 13 into this. You can see my calculator. I'm going to go negative 4 times 13 hours plus the 80. So my resting heart rate would be 28. Now that really doesn't make sense because that's super slow. That's like an elephant's heart rate. But hopefully you're understanding the idea. And you know what? Let's just stop right there. I'm happy with this, and I'll see you in class.